Hey everyone, welcome back to Engineer Empire. I'm a software engineer turned corporate VP and head of technology. I dive into topics like engineering, finance, and business. If that interests you, please hit like or subscribe. Today I'm reacting to how water recycling works.
Wichita Falls, Texas went through the worst drought in its history in 2011 and 12. For 2 years in a row, the area saw its average annual rainfall roughly cut in half, decimating the levels in the 3 reservoirs used for the city's water supply. Looking ahead, the city realized that if the hot, dry weather continued, they would be completely out of water by 2015. 3 years sounds like a long runway, but when it comes to major public infrastructure projects, it might as well be overnight. Between permitting, funding, design, and construction, 3 years barely gets you to the starting line.
That sounds pretty inefficient to me. 3 years is a good chunk of time, at least like coming from a software engineering background. 3 years is basically unheard of for you to get as a timeline to work on anything at all. And so to be able to have 3 years and basically that just scratching the surface of your project for some of these engineering projects that happen in the real world, it seems like a lot of overhead and inefficiency that must be going on there.
So the city started looking for other options. And they realized there was one source of water nearby that was just being wasted. Millions of gallons per day just being flushed down the Wichita River. I'm sure you can guess where I'm going with this. It was the effluent from their sewage treatment plant. The city asked the state regulators if they could try something that had never been done before at such a scale. Take the discharge pipe from the wastewater treatment plant and run it directly into the purification plant that produces most of the city's drinking water. And the state said no. So they did some more research and testing and
I guess not very surprising that they said no at first request. It is kind of gross when you think about it, that they're just pumping the wastewater into like a purification plant, presumably for use, maybe human use, maybe for alternative use, but still, I can understand why there's an initial skepticism on this.
ask again. By then, the situation had become an emergency. This time, the state said yes, and what happened next would completely change the way cities think about water. I'm Grady, and this is Practical Engineering. You know what they say, wastewater happens. It wasn't that long ago that raw sewage was simply routed into rivers, streams, or the ocean to be carried away. Thankfully, environmental regulations put a stop to that, or at least significantly curbed the amount of wastewater being set loose without treatment. Wastewater plants across the world do a pretty good job of removing pollutants these days. In fact, I have a series of videos that go through some of the major processes if you want to dive deeper after this. In most places, the permits that allow these plants to discharge set strict limits on contaminants like organics, suspended solids, nutrients, and bacteria. And in most cases, they're individualized. The permit limits are based on where that effluent will go, how the water body is used, and how well it can tolerate added nutrients or pollutants. And here's where you start to see the issue with reusing that water. Clean enough is a sliding scale. Depending on how water is going to be used or what or who is going to interact with it, our standards for cleanliness vary. If you have a dog, you probably know this. They should drink clean water, but a few sips of a mud puddle in a dirty street, and they're usually just fine. For you, that might be a trip to the hospital. Natural systems.
Yeah, hopefully not too many people are drinking dirty water. Obviously, there's folks who are in other countries that maybe have less direct access to water, and even other countries is probably a stretch. Obviously, even America, sometimes there's been natural disasters or some infrastructure problems that lead people to losing access to clean drinking water. So hopefully people aren't doing this too often. But obviously dogs, they do it once in a while and are okay.
Can tolerate a pretty wide range of water quality, but when it comes to drinking water for humans, it should be very clean. So the easiest way to recycle treated wastewater is to use it in ways that don't involve people. That idea has been around for a while. A lot of wastewater treatment plants apply effluent to land as a disposal method, avoiding the need for discharge to a natural water body. Water soaks into the ground, kind of like a giant septic system, but that comes with some challenges. It only works if you've got a lot of land with no public access and a way to keep the spray from drifting into neighboring properties. Easy at a small scale, but for larger plants, it just isn't practical engineering.
So I'm not sure if he specifically mentioned when he went over it. He mentioned going from the waste plant basically to a processing plant or a cleaning plant. And so he's sort of covering other uses for water, or like sort of clean water, like dirty-ish water that we wouldn't necessarily drink, but is still usable for things. And so this is definitely common practice in especially other countries and even certain parts of the US. So it's not clear if he's saying that that plant used this to kind of siphon off and reuse some water for certain purposes, or if he was actually planning to have that plant cover drinkable water for humans. Maybe he'll share that soon.
Plus, the only benefits a utility gets from the effluent are some groundwater recharge and maybe a few hay harvests per season. So why not send the effluent to someone else who can actually put it to beneficial use? If only it were that simple. As soon as a utility starts supplying water to someone else, things get complicated because you lose a lot of control over how the effluent is used. Once it's out of your hands, so to speak, it's a lot harder to make sure it doesn't end up somewhere it shouldn't, like someone's mouth. So naturally, the permitting requirements become stricter. Treatment processes get more complicated and expensive. You need regular monitoring, sampling, and laboratory testing. In many places in the world, reclaimed water runs in purple pipes so that someone doesn't inadvertently connect to the lines thinking they're potable water. In many cases, you need an agreement in place with the end user, making sure that they're putting up signs, fences, and other means of keeping people from drinking the water. And then you need a plan for emergencies. What to do if a pipe breaks, if the effluent quality falls below the standards, or if a cross connection is made accidentally. It's a lot of work, time, effort, and cost to do it safely and follow the rules, and those costs have to be weighed against the savings that reusing water creates. In places that get a lot of rain or snow, it's usually not worth it. But in many US states, particularly those in the Southwest, this is a major strategy to reduce the demand on fresh water supplies. Think about all the things we use water for where its cleanliness isn't that important. Irrigation is a big one, crops, pastures, parks, highway landscaping, cemeteries, but that's not all. Power plants use huge amounts of water for cooling, street sweeping, dust control. In nearly the entire developed world, we use drinking quality water to flush toilets. You can see there might be cases where it makes good sense to reclaim water, and despite all the extra challenges, its use is fairly widespread. One of the first plants was built in 1926 at Grand Canyon Village, which supplied reclaimed water to a power plant and for use in steam locomotives. Today, these systems can be massive, with miles and miles of purple pipes run entirely separate from the freshwater piping. I've talked about this a bit on the channel before. I used to live near a pair of water towers in San Antonio that were at 2 different heights above ground. That just didn't make any sense until I realized they weren't connected. One of them was for the reclaimed water system that didn't need as much pressure in the lines. Places like Phoenix, Austin, San Antonio, Orange County, Irvine, and Tampa all have major water reclamation programs. And it's not just a US thing. Abu Dhabi, Beijing, and Tel Aviv all have infrastructure to make beneficial use of treated municipal wastewater, just to name a few.
So that's an interesting point he makes there. We've covered a few different topics on this channel already, including some like natural disasters and issues that can arise in architecture and infrastructure for America or for other countries. And so one of the things that is interesting to me is, for instance, what he just mentioned, water can be very scarce in certain parts of America. And it's interesting how something in sort of more of a desert type region, they think about how to get water and to avoid droughts regularly. But then there's segments of like the coasts where they just have so much water that like they don't know what to do with it. Florida, for instance, like having too much water around, not necessarily drinkable water, but too much water in general, is a huge issue for them. And how different parts of America, because it is so geographically diverse, has to kind of focus in on different problems that other states might not care about at all. And so it's interesting to me that this exists. We've also kind of covered some of these topics in the past, but I believe Phoenix, Arizona also is doing a lot into water conservation because they're starting to add more industry and manufacturing there. And so they already had limited water supply. And as manufacturing and kind of more industrial tasks take on, they need more water to help process, deal with waste, etc. And I think even like Las Vegas, I believe, is another area that's kind of famous that also does a lot to kind of retain their water and be good users of their water since water is much more scarce in their area.
Because of the extra treatment and requirements, many places put reclaimed water in categories based on how it gets used. The higher the risk of human contact, the tighter the pollutant limits get. For example, if a utility is just selling effluent to farmers, ranchers, or for use in construction, exposure to the public is minimal. Disinfecting the effluent with UV or chlorine may be enough to meet requirements. And often that's something that can be added pretty simply to an existing plant. But many reclaimed water users are things like golf courses, schoolyards, sports fields, and industrial cooling towers where people are more likely to be exposed. In those cases, you often need a sewage plant specifically designed for the purpose, or at least major upgrades to include what the pros call tertiary treatment processes, ways to target pollutants we usually don't worry about and improve the removal rates of the ones we do. These can include filters to remove suspended solids, chemicals that bind to nutrients, and stronger disinfection to more effectively kill pathogens. This creates a conundrum, though. In many cases, we treat wastewater effluent to higher standards than we normally would in order to reclaim it, but only for non-potable uses with strict regulations about human contact. But if it's not being reclaimed, the quality standards are lower and we send it downstream. If you know how rivers work, you probably see the inconsistency here, because in many places, down the river is the next city with its water purification plant whose intakes in.
It's a good point that he's making, which is you can just kind of like push the problem downstream, literally, and have somebody else worry about dealing with that water. Though I would guess at least there are normal things that happen, like natural systems that exist to kind of help purify water. Like, for example, some of the sediment that could exist would probably settle towards the bottom of a river and maybe not necessarily be intaken for one of their purification plants, for instance. They might take that higher up to avoid some of that sediment that could occur. I'm sure there's also like dilution from rainwater, for instance, could exist. And so like there's other water sources that are maybe connecting back into this river other than this wastewater. So maybe it becomes less harmful there naturally. So that does seem slightly different here.
In effect, reclaim that treated sewage from the people upstream. This isn't theoretical, it's just the reality of how humans interact with the water cycle. We've struggled with the problems it causes for ages. In 1906, Missouri sued Illinois in the Supreme Court when Chicago reversed their river, redirecting its water and all the city's sewage toward the Mississippi River. If you live in Houston, I hate to break it to you, but a big portion of your drinking water comes from the flushes and showers in Dallas. There have been times when wastewater effluent makes up half of the flow in the Trinity River. But the question is, if they can do it, why can't we? If our wastewater effluent is already being reused by the city downstream to purify into drinking water, why can't we just keep the effluent for ourselves and do the same thing? And the answer again is complicated. It starts with what's called an environmental buffer. Natural systems offer time to detect failures, dilute contaminants, and even clean the water a bit. Sunlight disinfects, bacteria consume organic matter. That's the big difference in one city, in effect, reclaiming water from another upstream. There's nature in between. So a lot of water reclamation systems, called indirect potable reuse, do the same thing. You discharge the effluent into a river, lake, or aquifer, then pull it out again later for purification into drinking water. By then, it's been diluted and treated somewhat by the
I think with where he's going and the topics he's covered, I think this plant is likely trying to use wastewater directly for potable and drinking use. I think he's been kind of going through this journey of highlighting how challenging it is, just so that way we can like appreciate the issues that can arise and the challenges that occur there. Just because he's been going through these sort of like step by step, he's kind of talked about how we don't use water from waste for most cases. There's different regulations around it, and you need to do different amounts of testing and purification. And then he goes into the fact that like this system sort of exists today across cities that use similar or attached water sources where discharge will go from one location and then that will basically be an inflow for the next location. And so while there is natural processes and some time there, we're not too far from it. So I'm assuming he's going to get to the point where like he's actually describing how they make water drinkable from like an actual waste pipeline without there being sort of like nature involved or a lot of extra water in that process.
The natural systems. Direct potable reuse projects skip the buffer and pipe straight from one treatment plant to the next. There's no margin for error provided by the environmental buffer, so you have to engineer those same protections into the system. Real-time monitoring, alarms, automatic shutdowns, and redundant treatment processes. Then there's the issue of contaminants of emerging concern. Pharmaceuticals, PFAS, personal care products, things that...
This I didn't think about, which is like, well, people just like flush things sometimes, like care products or medications, I guess, presumably, or maybe even other like cleaning supplies, presumably, like you're cleaning your toilets and other things or showers. So like there should be chemicals for sure that are entering into that water that you wouldn't normally think to drink. So this makes sense that there's a lot of things that you'd have to start considering once you plan to use that as drinkable water.
Pass through people or households and end up in wastewater in tiny amounts. Individually, they're in parts per billion or trillion, but when you close the loop and reuse water over and over, those trace compounds can accumulate. Many of these aren't regulated because they've never reached concentrations high enough to cause concern, or there just isn't enough knowledge about their effects yet. That's slowly changing, and it presents a big challenge for reuse projects. They can be dealt with at the source by regulating consumer products, encouraging proper disposal of pharmaceuticals instead of flushing them, and imposing pre-treatment requirements for industries. It can also happen at the treatment.
I'm actually not sure how often people flush pharmaceuticals. I don't know if any of you do this, but feel free to post it in the comments below. But I don't think I've ever disposed of pharmaceuticals this way, but I don't really have that many of them to begin with, but there's like trash cans and stuff. I'm not sure why specifically you would use a toilet unless you're trying to like make sure you can't get it back in any way, or like you're trying to hide usage of it or something. I'm not really sure, but maybe if you guys do this, post in the comments below, let me know why you would do this or like if there's a good use case for it. But it doesn't seem necessary to me.
Plant with advanced technologies like reverse osmosis, activated carbon, advanced oxidation, and bioreactors that break down microcontaminants. Either way, it adds cost and complexity to a reuse program, but really, the biggest problem with wastewater reuse isn't technical, it's psychological. The so-called yuck factor is real. People don't want to drink sewage. Indirect reuse projects have a big benefit here. With some nature in between, it's not just treated wastewater, it's a natural source of water with treated wastewater in it. It's kind of a story we tell ourselves, but we lose the benefit of that with direct reuse. Knowing your water came from a toilet, even if it's been purified beyond drinking water standards, makes people uneasy. You might not think about it, but turning the tap on, putting that water in a glass, and taking a drink is an enormous act of trust. Most of us...
Agreed. It is odd if you have to think about it actively. I would guess most people probably in those cities don't even know. I would say honestly, even for my own city, I don't know what percentage, if any, of the water comes from waste treatments, or like what waste treatment goes into the water sources for mine. There is a lot of trust that's involved in it. I think something that would help me a little bit more when I think about it is there are natural processes that do this. Like, this happens all the time. Obviously, waste from animals and other things are out in the wild, and there's natural processes to help deal with this issue. And it's not like new water is being created all the time. So, like, water is kind of going through this life cycle of being used, kind of going back into the earth, kind of going back up into the atmosphere, coming back down. And so there's definitely a variety of processes that are sort of naturally recycling water. So almost certainly all water has been part of waste at some point in time for it to have basically gotten to you. So that would help me a bit, but I agree there is kind of an ick factor for it.
Don't understand water treatment and how it happens at a city scale, so that trust that it's safe to drink largely comes from seeing other people do it and past experience of doing it over and over and not getting sick. The issue is that when you add one bit of knowledge to that relative void of understanding, this water came directly from sewage, it throws that trust off balance. It forces you not to rely on past experience, but on the people and processes in place, most of which you don't understand deeply, and generally none of which you can actually see. It's not as simple as just revulsion. It shakes up your entire belief system, and there's no engineering fix for that. Especially for direct potable reuse, public trust is critical. So on top of the infrastructure, these programs also involve major public awareness campaigns. Utilities have to put themselves out there, gather feedback, respond to questions, be empathetic to a community's values, and try to help people understand how we ensure water quality no matter what the source is. But also, like I said, a lot of that trust comes from past experience. Not everyone can be an environmental engineer or licensed treatment plant operator, and let's be honest, utilities can't reach everyone. How many public meetings about water treatment have you ever attended? So in many places, that trust is just going to have to be built by doing it right, doing it well, and doing it for a long time. But someone has to be first. In the US, at least on the city scale, that drinking water guinea pig was Wichita Falls. They launched a massive outreach campaign, invited experts for tours, and worked to build public support. But at the end of the day, they didn't really have a choice. The drought really was that severe. They spent nearly 4 years under intense water restrictions. Usage dropped to a third of normal demand, but it still wasn't enough. So, in collaboration with state regulators, they designed an emergency direct potable reuse system. They literally helped write the rules as they went, since no one had ever done it before. After 2 months of testing and verification, they turned on the system in July 2014. It made national headlines.
Wow, 2014. I did not notice this at all. I'm not that close to Texas, so maybe I just wasn't paying that close of attention. But that's cool that this has actually been going on for quite some time. So that means this is likely very, very safe and probably used in a number of cities now in America.
The project ran for exactly 1 year. Then, in 2015, a massive flood ended the drought and filled the reservoirs in just 3 weeks. The emergency system was always meant to be temporary. Water essentially went through 3 treatment plants: the wastewater plant, a reverse osmosis plant, and then the regular water purification plant. That's a lot of treatment, which is a lot of expense, but they needed to have the failsafe and redundancy to get the state on board with the project. The pipe connecting the 2 plants was above ground and later repurposed for the city's indirect potable reuse system, which is still in use today. In the end, they reclaimed nearly 2 billion gallons of wastewater as drinking water, and they did it with 100% compliance with the standards. But more importantly, they showed that it could be done, essentially unlocking a new branch on the skill tree of engineering that other cities can emulate and build on.
Thank you for watching. I will see you around.